These accidents with dangerous goods show how important it is to observe the ICAO and IATA regulations closely. What makes dangerous goods so hazardous? It is their properties, and that is why the ICAO has classified these substances into 9 hazard classes. Let's start with Class 1. This class comprises all explosives. Included in this class, we find practice ammunition, plastic, military and technical explosives and ammunition used in hunting and sports. Most explosives are not transported by air as they are too dangerous. Here is a parcel containing 5 kilograms of TNT and its effect. But even small amounts are enough to cause a lot of damage. For this reason, explosives from 2 divisions only may be transported by air. Explosives in Division 1.3 with the compatibility letters C and G, and explosives in Division 1.4. What are their properties? 1.3 C and G are flammable. There is little risk of splinters, fragments, and broken pieces. Division 1.4 contains substances and objects which are not significantly dangerous. For example here, these flares and smoke signals. Compatibility Group S is of a particular interest. This group includes safety ammunition, for example, sub-caliber ammunition for weapons used in hunting and sports. Summarizing once again the properties of the explosives which may be transported by air: fire risk, low risk of explosion and splinters. Let's have a look at Hazard Class 2, the gases. This includes compressed, liquefied or frozen gases and those which are dissolved under pressure, as well as mixtures of gases and aerosols. Gases can be transported in pressurized containers. This container is filled with 300 grams of a non-flammable gas, carbon dioxide. If the container or seal is damaged, the effect is similar to a gunshot in the hold of an aircraft. Spray cans are also pressurized containers and can burst if they are exposed to high temperatures or a drop in air pressure. That's why pressurized containers must never be heated or damaged. The various Class 2 labels, apart from showing the general pressure risk, also indicate additional properties. This red label indicates flammable gases of the Division 2.1. Here is a demonstration with hairspray. Besides, when gases and air are mixed in the right proportion, this can lead to an explosion. This balloon is filled with a mixture of gas and oxygen. You can imagine the effect in the hold of an aircraft. The green label stands for non-flammable, non-poisonous gases of Division 2.2. They can have either an oxidizing or asphyxiating effect. These gases can be extremely cold. Liquid nitrogen, for example, can be as cold as minus 192 degrees Celsius. A rose dipped into it freezes within seconds. And shatters like glass. These gases are heavier than air. They displace the oxygen and make breathing impossible. We now come to the gases which are also poisonous. They belong to division 2.3. Poisonous gases spread very quickly. If inhaled, they can cause serious health problems or even death. Not normally allowed to be transported on passenger aircraft. Let's summarize the facts. Class 2 gases are often transported in pressurized containers. These containers can burst. Depending on their other properties, these gases can be flammable, produce low temperatures, displace air, be poisonous. Flammable liquids come under Class 3. This class comprises liquids which give off flammable vapors, for example, varnish, solvents, lighter fuel, kerosene, and adhesives. These substances have varying flash points. This is defined as the lowest temperature at which the vapor coming from a liquid can be ignited in air. By the way, the boiling point is an important factor when classifying the substances. These include all liquids which are measured to have a flash point of 60.5 degrees Celsius or less in a closed container, or 65.6 degrees Celsius in an open container. Isopropanol, an alcohol, gives off enough flammable vapor at 10 degrees Celsius. Room temperature and a warm spatula are enough to ignite carbon disulfide. Kerosene, it does not burn at room temperature. It must be heated to over 40 degrees Celsius before it emits enough flammable gas. Summarizing, the dangerous goods from Class 3 are flammable at temperatures from 60.5 or 65.6 degrees Celsius or below. Hazard Class 4 has 3 divisions. Division 4.1 includes flammable solids. For example, here, nitrocellulose, also known as gun cotton. What are its properties? It burns very quickly. These substances can ignite as a result of frictional warmth or heat. Substances with this label belong to Division 4.2. These substances are difficult to film in a studio as they combust spontaneously in air. They include, for example, white or yellow phosphorus. Division 4.3 includes those substances which form flammable gases when in contact with water. Let's observe carbide. It does not burn when dry. However, when water is added, flammable gases evolve. Let's summarize the properties from Class 4. Flammable solids which ignite spontaneously form flammable gases with water. Hazard Class 5 has two divisions: oxidizing substances and organic peroxides. Both can promote or start fire because they emit oxygen. With the aid of a welding nozzle, it can be seen that when oxygen is added to the flame, it turns blue. The flame gets hotter and combustion is intensified. The same effect can be observed with the oxidizers in Division 5.1. For example, potassium permanganate. Here also the flame turns blue and combustion is accelerated. Organic peroxides also stimulate combustion. As here with benzoyl peroxide, they combust explosively. There are also organic peroxides which react spontaneously with other chemicals, for example, glycerine, and combust on their own. Let's repeat. Both divisions promote fire, react dangerously with other substances, are sensitive to heat and friction. The dangerous goods in Class 6 are divided into two divisions: toxic substances and infectious substances. Toxic substances carry this label. Here are some examples of the commercial products in this division. These substances are not only poisonous when swallowed, but also when inhaled or in contact with skin. Great caution is therefore required when dealing with damaged parcels. Infectious substances belong to Division 6.2. These are microorganisms or in this case, bacterial cultures for research. Infection is possible on contact. Let's summarize. Substances in class 6 are poisonous or pathogenic. Consequences: infection, disease, death. Now we come to the radioactive substances in class 7. These substances are used in medicine, industry, and in nuclear engineering to obtain energy. Our senses cannot detect the radioactivity emitted by these substances, but by using technical aids, like for example this Geiger-Müller counter, it is possible to detect the radiation, the level being given as an audible signal. Radioactivity arises from the breakdown of atoms. They emit such high energy that the rays can penetrate this block of iron. We must therefore protect ourselves. But how? The best protection is to keep your distance. You can hear that the radiation decreases. Time is another protective factor. The shorter the time spent in a radioactive area, the less the amount of radioactivity absorbed by the body. A part of the radioactivity can be shielded, and in practice this is achieved by using special packaging. The International Atomic Energy Agency has laid down maximum limits for cargo with radioactive contents. These limits also provide protection and apply to 3 categories of parcels. Parcels with this label emit the least amount of radioactivity, and parcels with this label emit the most. Let's summarize. Radiation damages the environment. You can protect yourself by keeping your distance, limiting the time spent in the radioactive area, shielding the radioactivity, and observing maximum limits. Corrosive substances, such as acids and alkalis, belong to hazard class 8. Here we are adding hydrochloric acid to aluminium, a light metal, which is also used in building aircraft. As you can see, gases are evolved immediately, and the aluminium is broken down. Concentrated alkaline solutions have a similarly vigorous reaction. What are the properties of acids and alkaline solutions? They produce heat and gases, destroy living tissue and other material. All those dangerous goods with properties which have not already been discussed belong to class 9. For example, vehicles, magnetic substances, and dry ice. Dry ice is very cold, minus 70 degrees Celsius. However, as it only becomes gaseous when warmed and does not produce any moisture, it is the ideal cooling agent for transportation. The gas formed, however, does have a disadvantage. It is heavier than air and displaces oxygen. That is why rooms used to store dry ice, for example here in the hold of an aircraft, must be aired before entering. Let's look at another example from Class 9, a magnet. Magnets do not place people at risk directly, but they form magnetic fields which may influence compasses, videotapes, data storage media and measuring equipment. Let's summarize. Dry ice is very cold. It displaces air. Magnets influence instruments and destroy information on data storage media. You are now familiar with the most important properties of dangerous goods. Please observe the ICAO and IATA regulations and thus ensure that these properties never come into effect.